Oh my goodness. Hello. Hi. Welcome to a ramble. We are looking at paper one from IEB's November 2022 session. Right. Today's focal question is question 3C. In the diagram below, f of x is equal to x squared minus 2x minus 3. A is the y-intercept and B is an x-intercept of f. The first question, which is confusingly up here, calculate the coordinates of A and B. Okay, so y coordinate we get by we make x equal to 0. So f of 0 is equal to 0 squared minus 2 times 0 minus 3. Right, so the coordinates of A will be 0 and minus 3. And then for B, we make our y equal to 0. So that will be, okay, I'm going to need to make this question just a bit less vigorous in size. Okay. Right, so we have 0 is equal to x squared minus 2x minus 3. 0 is equal to x minus 3 times x plus 1. Therefore, x is equal to 3 or x is equal to minus 1. Okay, and we can see that b is on the positive x-axis, so x b is greater than 0, so x is equal to 3. Therefore, the coordinates of b are 3 and 0. Okay, right, let's check with the memo if we're on the right track. Yes, we are. Okay, cool. So determine the coordinates of the point on F where the tangent to F is parallel to line AB. Okay, so we're looking for, oopsie. So AB is that line over there roughly, not really. Okay, and we are looking for the point where the tangent is parallel to that line. So the tangent has the same gradient as AB. So we're going to need to find the gradient of AB. We're then going to need to find the gradient function of the parabola and figure out which value of x makes that gradient function equal to this gradient of AB, right? And then once we have that x value, we can then figure out the y value by putting it into the parabola's function. So then we get the coordinates. Cool. So as it turns out, my ruler had a angle of inclination of 45 degrees, which would mean that the gradient of AB is in fact 1. So let's see if that is true, and I think it is true. So that's 0 minus minus 3 at the top, my y coordinates, and then my x coordinates 3 minus 0. So we end up with positive 3 over 3, which is indeed 1. Okay, these diagrams are not necessarily drawn to scale, so you can't rely on calculations like that. But anyway, I guess if you're desperate, you could, and see how far that gets you. Okay, so now we want to find our gradient function. So if we find the first derivative, we get 2x minus 2. And we now want to find which value of x makes this gradient function not equal 0. We're not trying to find a turning point. We want to see where the gradient is equal to 1. So we want to see where this expression is equal to positive 1. Which means we are solving for 2x is equal to 1 plus 2, which is 3. And if we divide by 2, that will be x is equal to 3 over 2. Okay, so we know that, yeah, the tangent will have a gradient of 1 when x is equal to 3 over 2. So the last piece of the puzzle, we just need to find what is the y value when x is equal to 3 over 2. So that will be 3 over 2 squared minus 2x minus 3. So minus 2x minus 3. not in the mood to do the head math. So that is negative 15 over 4. Okay, right. So it will happen at the point 3 over 2 and negative 15 over 4. We agree? We agree. Perfecto. Right, cool question. And just bringing in a little bit of that analytical geometry, our every so often reminder that it's a good idea to bring both your paper 1 and your paper 2 knowledge into either paper. Cool stuff. See you another time for another ramble.